Hello everyone and welcome to the First Thursday Club for October. I hope everyone's well. Today we're going to be hearing about the whole life carbon management for buildings and infrastructure, a guide to reducing emissions. Before that though, there is some housekeeping. Those of you that have joined these First Thursday Clubs before won't be surprised about this. But yes, we mute everybody's microphones for obvious reasons. But there is a option to ask questions through the dialog box, and we welcome those questions. So if you could pop those in as Jamie's talking, then that would be great. I will look at those as Jamie's talking and organise the Q&A at the end. So please just, whenever you think of something, pop it in there. After the presentation, we'll be emailing out a questionnaire, which helps us with your feedback, helps us tweak things as we go with these First Thursday Clubs. So our speaker today is Jamie Blunden. He's a principal carbon consultant within Nature Positive's carbon and sustainability team. He has extensive experience addressing sustainability and greenhouse gas emissions within the construction industry, where he's worked with clients on both project and organisational levels. This is delivering all scopes, greenhouse gas emissions assessments, building and infrastructure whole life cycle carbon assessments and carbon management plans. Previously, Jamie's worked on phase 2A of HS2, unfortunately, project identifying and reducing whole life carbon emissions via the HS2 carbon management standard PAS 2080. So without further ado, I'll hand over to Jamie.
Thank you very much, Tim. Sorry for the tongue twisters that I put in there. Welcome everyone. Thank you for joining. Yeah, looking forward to presenting on this topic for you. So, our agenda for today. So we're going to start off with a little bit of context as to why I'm talking about this and sort of the background to a couple of the publications that I'm going to be basing this talk on. We'll then go through how we might conduct a whole life carbon assessment and then how we can use carbon management itself as a tool. So, you know, what were my motivations for doing this talk today? As an industry, you know, the built environment and infrastructure, both at a national level and international level, has a significant impact on our greenhouse gas emissions. In 2021, globally, it accounted for around 37% of process-related greenhouse gas emissions. And then similarly for the UK, the construction, manufacturing and use emissions from buildings and infrastructure account for around 32%. So we're a big deal in terms of what we need to do to help us get towards our net zero 2050 target, and there's a big step to take there. And again, I think previously there's been a focus on sort of energy efficiency, which now sees buildings designed with low energy usage in mind as a standard practice with the use of PV or other renewable energies. The same thinking should become commonplace for the rest of our buildings emissions, so that really we can work together and in conjunction with this energy efficiency get to where we want to be. So the first point really is, you know, what do we mean by whole life carbon? So whole life carbon emissions are the sum of all asset related greenhouse gas emissions and removals, operational embodied over the life cycle of an asset, including its disposal. So that is anything from sort of your products through to any of your energy usage in operation, through to any maintenance emissions, through to the end of life, and then sort of any biogenic carbon, etc., that you might include in there. Whole life carbon assessment itself is governed by a plethora of EN standards. So the modules I just mentioned previously come from EN 15978, and then really there are a series of documents that build on those standards and make them a bit more digestible. So the two documents that I will use today to frame the discussion that I'm going to be giving is PAS 2080-2023, which is the recently released updated PAS 2080 standard for carbon management in buildings and infrastructure, and the RICS professional statement on whole life carbon for the built environment. Again, a second edition recently released. It's a quick summary of what PAS 2080-2023 is. So this is a specification document which can be used by organisations to create an effective carbon management system. and it's not a methodology for completing the assessments. So it'll tell you what your management system should include, but not how to do it. It is applicable to all members of the value chain. So that's from your asset owners through to your designers, constructors, and your product suppliers. And very handily, it's got this accompanying ICE guide, which was written by the same technical authorship group of the PAS, which accompanies it and is well worth checking out. The second publication we'll be using and talking about is the RICS professional statement. And now this is the methodology document, and it's designed to aid the standardization of whole life carbon assessments across the built environment. It does provide guidance on assessment scopes, the timeframes and data requirements required for a project's lifespan, and includes things such as like a standard specification for early stage design. It can be used in conjunction with PAS 2080. So this is sort of a bolt-on that fits into the system, but isn't a carbon management system in itself. So the first stage that we're going to look at, building on it, focuses on this document and some of the information within it, and that is conducting a whole life carbon assessment. So what's included in a whole life carbon assessment? I think the first point to make is that an embodied carbon assessment does not equal a whole life carbon assessment. We're seeing, as it's quite a new area still, we're seeing those words somewhat used interchangeably. And it's just important to note there is a distinction between the two, and I'm trying to help raise awareness of that, and hopefully as part of today's presentation you'll understand what I mean by that at the end. So as you can see, there's quite a few different boundaries that we can look at, and generally the different stages are presented in these modules, which each have a letter attached to them. So we've got module A, which is the upfront carbon, and that between it is split into pre-construction, so A0, which looks at any sort of that's good, that's a tongue twister, looks at testing before the building starts. So that could be any boreholes, that could be any ground stabilization testing, etc., soil sampling that is required prior to construction. And then we've got A1 to A3, which is what we call the product assessments. And this is your traditional embodied carbon, what you think of when you think of embodied carbon. So this includes the extraction of, say, if we look at steel, for example, so the extraction of the ores, and then the transportation to its manufacturing center, and then of course the emissions from the manufacturing of them. So that's what we call the product stage. Next up is the construction stage, and that looks at the transportation from the factory to the construction site, as well as any emissions generated from, say, the construction plant, the compound, the waste, the water, you know, the standard sort of things that you may be collecting as part of your general reporting anyway. The next stage is the use stage. This looks at from B1 to B8. So B1 to B5 are typically, these are emissions that are generated from maintenance, use, repair, replacement and refurbishment of an asset or a building. And what does that mean? So we take a road, for example, the repair and replacement of the running surface, the replacement of the blacktop, that would fall under, say, B4 across the lifespan after the initial layer had been put down, if that makes sense. We've then got B6 and B7, which looks as referred to as operational carbon. And this again is maybe, you know, where this typically energy efficiency focus has been previously. It's been looking at sort of how can we reduce the operational energy over the building's lifespan? How can we lower water? And that is still included within the whole life carbon system boundary. And then finally, B8, that will look at things such as like vehicle emissions, etc., for assets where they're relevant. C1 to 4 is defined as end of life. This can be quite confusing and a bit tricky to sort of comprehend, as obviously we're building a building in or a piece of road in or whatever in 2023, but we need to work out how it's going to be constructed in 60 or 120 years. So, you know, what is that going to look like? And that can be quite daunting for design teams and sort of practitioners. So what that looks like is any sort of emissions from deconstruction or demolition, emissions from transporting that waste from the site to the waste disposal centre, and then the process and disposal emissions of that waste. Hopefully, you know, with the buildings constructed now in 60 years, circular economy will be a much larger part of the way we deal with building materials, so there won't be as many disposal emissions, and we'll be looking to reuse them more, which is where module D comes in, which looks at the benefits and loads beyond the system. So the reuse of products, the carbonisation of anything, or the sequestration of, say, timber and building materials throughout the life cycle of the project. So that's what's covered in an LCA. So when should a project conduct a whole life carbon assessment? So you never really, you know, personally from a practitioner point of view, it's never too early to start considering whole life carbon. I think a key point of this presentation I'd like everyone to take away is that the ability to influence whole life carbon and reduce it is greatest during the early design stage. And it starts with basically assessing the need for new construction, the need for the project to be completed, which is a bit of a juxtaposition as we are talking about the construction industry. You know, what we do is we build new buildings and assets. That's how we make the money. But, you know, really important to consider retrofitting. Can we refurbish an asset to do the same job? Do we need to knock it down and start again? And you know, obviously the quality of the data and the accuracy of the assessment will not be as accurate as when you're standing there with the final as-built bill of quantities and the in-use energy data, but we can't let that be a deterrent to starting to assess things early on. And it's a sequential process. So as this graph shows, you know, the continuation of whole life carbon assessments throughout the project, you'll see a decrease in the potential to influence whole life carbon, but a much greater, but conversely, a large increase in the accuracy of the assessment as we get to the end of the project. Apologies. So data requirements, again, this is just to illustrate that point I was making. So at an early stage, we'd be looking for things sort of like industry guidance, standard assumptions based on other buildings' data. If there are outline drawings or BIM models, we can do quantity takeoffs to look at those. But as the table shows, you know, as we move through the project, the applicable data sources differ as the project matures and it starts asking for more data. At the early design phase, the RICS document does provide generic material specifications. There's other calculation tools such as OneClick LCA, which we use, that can help us assist a client in creating a baseline from which they can start to plan reduction from. And there's also launched today the Built Environment Carbon Database, which will be looking to publish benchmark figures in terms of floor area, so that projects can set their own benchmarks and reduction targets at an early stage. As we move through to technical design, this is where we sort of start to add in a bit more data. We get the specifications and the construction methodologies from different parts of the supply chains, and we start replacing some of that generic stuff that we put in to start with and layering in the data. And then finally is the post-completion stage, and that's probably what actual quantities. And it's really important that we get these as accurately as possible, as it's a key to validating the hard work of the design stage and calculating the performance gap that we might see in a asset, for example. And then reporting. So once we've sort of got this data, how do we report it? So assessments are always reported over a standardized reference period. So this for domestic and non-domestic buildings is 60 years. And then for civil engineering and infrastructure projects such as rail, road, some types of quarry, these are 120 years. It's also worth noting that whole life carbon assessments can be completed obviously for fit out projects with a shorter lifespan, but it's important to consider the impacts of, say, designing something for 10 years for then it all to be ripped out and done again. Is that really the best use of carbon that we've got in our current sort of awareness of what we need to do to reduce emissions. So it's a standardized reporting period, but there's also a standardized method of reporting uncertainty in whole life carbon assessments. It's very unlikely that something, especially at design stage, would ever be 100% accurate due to maybe potential changes in material specification or material quantities. So there are 3 different factors that are applied to results to account for this uncertainty throughout the design stage and the post-construction stage, and these must be reported honestly and openly as part of any whole life carbon report that is submitted to a client. But generally, there's the RICS professional statement has done a great job in standardizing reporting to allow for comparison across the industry. And again, another shout out to the Built Environment Carbon Database, which launched today, is taking a big step forward in how we're going to be able to share data with one another. It's an industry-led initiative, so we must use it, otherwise it won't be as an effective tool as we want it to be. So that is, to start with, that's, I guess, how we conduct a whole life carbon assessment. That was looking at the methodology side of things. So now we're going to sort of look at how we can take the method and then turn it into management and use it as a tool to help our businesses to decarbonise the built environment. So this next section is looking at the newly updated PAS 2080-2023 document. So why should we use it? It's a clear specification for companies to follow to manage carbon reduction across either their businesses or their portfolio of assets. A compliance system will integrate carbon management into leadership. It will cement carbon and whole life carbon considerations into decision making, and it will engage the supply chain to deliver continuous improvement. So what we're going to look at is, over the next few slides, these are 3 summary points from it. It's not an overview of the whole standard, it's just a few different bits in which we can go into a bit more detail about it there. So leadership. There's some very good examples of carbon leadership out there at the moment, and we need some more of that if we're going to be able to effectively manage and reduce our carbon going towards 2050. So effective leadership is required to enable the carbon management process to succeed, and it needs to be at every level of the supply chain. So within the PAS document, clause 5 has a series of requirements for both all value chain members, and then it goes into specifics considering sort of whether you're an asset owner, a designer, a constructor, or a product supplier. What is key to it all, though, is the assignment of carbon specific roles and responsibilities throughout it. So it wouldn't just be, it's maybe something to do with the environment, so it's an environment sort of problem, environment teams project. It's making sure that throughout each level of leadership and at each level of project, there is an understanding of what carbon means, what people's responsibilities are, what a project manager might have to do, what a designer might have to do. And also it will help businesses identify training needs, where have we got gaps, where do we need to understand, maybe it's methodologies for assessment or maybe it's a new process that needs to be put in. And above all, making sure that the resources available are sufficient to effectively manage the carbon in your business. There's also a strong commitment, or there should also be a strong commitment to sharing good practice. It's another key thing that's, whilst it's within this clause 5, it's throughout all of the PAS really. It's about the continual improvement and the sharing of good knowledge within the organisation so that people can get better ideas, and then sort of what once was maybe a special case becomes the norm in terms of maybe a concrete mix, maybe a way of designing the frame, etc. If you don't share the good practice that's done from a carbon point of view on one job, how else are you going to develop knowledge and skills and understandings within your organization? So that's leadership. That's the first thing that we focused on. The next one is looking at how we integrate both carbon and then whole life carbon management into decision making. So this is a graphic that I've taken from the PAS standard. Very good as it sort of lays it all out, really, how this is all meant to work. You can see leadership feeds through into each and every project or program of work, but then if you look at sort of the 4 key points surrounding the integration of carbon into decision making, it's the need for the continual improvement, it's the assessment, it's the monitoring and reporting, and it's the procurement that really fit together. That feeds into integrating carbon as a decision-making tool. So assessment, that's where the RICS professional statement could play in, because it allows a standardized methodology for you to assess carbon as a whole. Continual improvement will go back sort of to the leadership as well, about sharing good practice, showing what went well, but also sharing the pitfalls that you've had on projects and how we can not make those same mistakes again. Procurement, which I'll talk about in a minute, is about how we might incentivize our supply chain or our partners to provide us with low carbon solutions. And then monitoring and reporting, which is again part of the system with how are you monitoring your progress against any targets you've set, against any baselines you've set, both as a asset owner or portfolio of businesses, or against maybe a client supplied baseline. And that, as we move through every stage of the project, it is by doing these things, it will lead to a reduction in carbon, with carbon being the driver of the reduction opportunities. So building on what we've just discussed there, how do you then bring in the whole life carbon assessment principles to support decision making? So it'll build on that process that I've just described, and this is really more about understanding your study boundary and that considers emissions impacts across your value chain. So it's looking at wider than maybe your specific emissions as, say, a constructor. That would be your fuel use. It's about how, what emissions are being generated by your material suppliers, your subcontractors. What's the impact of your design choices on the actual operation and maintenance of the building? So it's important to consider the wider study boundary to fully understand your emissions impacts. And moving from sort of just thinking about carbon and how we can reduce it to looking at the lowest whole life carbon option is really a case of monitoring and just considering decisions both in the short term and then the full study, reference study period lifetime effects. So, if there is an initially lower embodied carbon option that maybe needs to be replaced 5 times as frequently over the lifespan of a project or a piece of infrastructure, is that really the best low carbon option compared to some of the other things available? And this is where it's important to make the distinction from just looking at low carbon to whole life carbon, as we can make sure that we're not making decisions which, for the best intentions are to be lower carbon, but actually have maybe a negative impact overall. And again, it's about ensuring that the level of accuracy, so looking at sort of, depending on where we are in a project, are we using very specific material supplies, or are we looking more at sort of generic material buildups or industry standard data because we need to fill some data gaps? And then the last little bit we're going to look at from the PAS standard is the procurement. So procurement is a new section that's been added to the 2023 standard. And really what it is it's asking people to move away from prescriptive specifications that don't allow really for innovation, which will enable designers or construction teams or even product suppliers to come forward and say, look, we have this low carbon alternative. Can we use this on the project? As part of it, it suggests maybe an incentive for for coming forward with these ideas, and that could be monetary, that could be access to further work, but at the same time, what we do need to see is a change in the attitude towards risk management. So it's all well and good encouraging low carbon options, but a lot of these are new, and potentially the longevity of the materials are untested compared to some of the more traditional or more commonly used material specifications that the clients are used to. So it needs to be a joint effort between client and value chain to make sure that when something is presented, risk is shared fairly, and that any potential information is exchanged up front on how that might be managed. Only then can we see a change in how we build things. And then finally, it's about clear communication of carbon targets coming both down from, say, client level, saying you must meet this number in terms of kilograms of CO2e per meter squared floor area, or you must meet a 50% reduction target from this baseline that we've given you, and that needs to be cascaded throughout the project so that everyone's clear on what we're trying to meet. There's no secret targets. But also from the supply chain side, they must be willing to share product information, any sort of carbon data they do have. If it is kept proprietary, then it doesn't actually assist the industry in moving forward and helping others to reduce their carbon and manage their carbon. So collaboration through the procurement process is really key if we are going to start moving towards a better understanding of carbon management as a whole. So I've sort of outlined there both, how you might conduct a whole life carbon assessment, and then, how you can take that initial understanding of a whole life carbon assessment and turn it into a tool for making different decisions. So it's probably not, it's not a secret, but a PAS 2080 carbon management system, which is third-party validated, is required by National Highways for their forthcoming integrated delivery framework. And it is likely that where one large client goes, others will follow. So a sensible next step would be to complete a gap analysis for your organisation to assess its maturity in terms of completing whole life carbon assessments, and then how we might take that and apply your carbon management systems to the PAS 2080 standard. And really it is just to say, we're here and ready to help with that. And yeah, so thank you for listening. I've put my my contact details on here. So there's both myself and then my director, Andy Greenall. And yeah, hopefully there's some questions there that some people might have. I'm happy to answer them.
Thank you very much, Jamie. Fantastic. We've got quite a few questions come in, but you can always use more. So if anything occurs to anybody while we're talking now, then just pop them in and we'll see if we can get around to them. First off, we have a question that says, what do you think the value of PAS 2080 is? Is it likely to be another tick box exercise? Very cynical approach.
So, well, we have seen with sort of previous sort of management systems that have become mandated by clients that, that people just want to get them done. It's there, but they don't get any value out of it. So an effective PAS 2080 management system will interact with some of your existing systems in terms of quality or environmental systems where you're already collecting data anyway. And it's not a whole new process, but the value of PAS 2080 ultimately is going to be what companies make of it. It might be mandated by certain clients to do work with them, and you could just see it like that. But I mean, yeah, it's cynical, but to get real value out of the whole process, you need to be engaged with it, and ultimately it would deliver better outcomes. It can increase, I think we will see sort of low carbon design options lead to greater investment from clients with certain contractors and certain designers. If you get your handle on your carbon, you're an advantage over people that are maybe just using it as a tick box exercise.
I think there was a question that's linked to that, but while I'm finding that one, I'll ask you the other one and we'll come back to that. This one was, should a WLC assessment form part of the planning approval stage?
Yeah, I genuinely think it should, and it does in some cases, sort of within London where there's referable developments. We've seen it as Part Z, which is it's a proposed bill in the House of going through the House of Commons at the moment, where certain projects over a certain size will be required to report on their, well, at least their embodied carbon. But really, I think if we've seen it recently with the M&S Oxford Street store. So that's the first planning application that's been turned down because of whole life carbon, because of this sort of the damage that knocking it down and rebuilding it would cause. I believe it's something like, it would be the same as driving a diesel car to the sun, just in terms of embodied emissions of knocking the building down before we've even started building it up again. So I think as we're running, as people are so keen to redevelop brownfield sites, especially in urban areas, then we sort of need to include whole life carbon assessments to enable planners to make the right choices as to whether, a shard-like structure is really the best use of the carbon that we have and in our remaining budget if we're going to reach net zero.
That's a staggering statistic, that one. There was the two questions, there were actually two that are sort of linked. I'll read both out. The first one was, do you think that procurement behaviour will realistically change from the standard SAFE approach? How can we incentivise the procuring party to take the risk? And then linked to that was re-procurement. How do you get suitable realistic buy-in if there is an adverse financial implication for the contractor?
So, I mean, it's tricky, and we've seen there's a new clause coming into the NEC contracts, which is one method that I've seen people are trying to address these climate change impacts, and that will be it's a climate change report basically, which would allow the contractor to submit an alternative specification with monetary cost attached to it to the client. So that's one way in which it could be managed. Ultimately, I think it's down to regulation from maybe a government level, maybe within the industry, that you could be cynical and say it's not going to change. But if there's a premium on poorly thought out or high embodied carbon goods, then at some point the low carbon option is going to become the cheaper option. So I think we will see it. I'm hopeful we'll see a change, but I can't say directly when that's going to be and sort of how specifically we might get there. But I think it is a fair question to say, is it realistically going to change? And I think we have seen that to some extent that it is already. So I'm hopeful.
That's good. Okay, how would you compare the RICS method of whole life carbon assessment versus the likes of OneClick LCA, or are they complementary?
So the OneClick LCA is compliant to the same standards the RICS is, and it actually has a tool that is in line with the RICS or the RICS. It's like Bream and Briam, you can call them either thing, sort of thing. That you can do a compliant assessment on the tool to the RICS standard. So that it's not one or the other. What I would say though is the OneClick is a great tool for completing the assessment, but this professional statement really is a fantastic resource for learning and understanding what goes into it, why certain assumptions are made, things around uncertainty, things around the decarbonisation of the grid. They're really complementary in the sense that you can complete the assessment on one, but it's almost like a textbook of how you might help out by using the two together.
Okay, I've got time for a couple more. This one is, are the data available good enough for us to be able to rely on the WLC report? I suppose this is getting to the point that a lot of these assessments are only as good as the data you've got in, and some of these are fairly tenuous or perhaps not very accurate or very precise, rather. Yeah,
so I mean, again, that is correct. The assessment is only as good as the data, but that's the same with sort of all greenhouse gas emissions assessments. But the way that the whole life carbon or RICS are proposing we account for this is through the uncertainty uplifts. So at early design stage, you had a 16% uplift at each module to account for the uncertainty in the design. And then going past that, at the different stages, you assess sort of the main materials and how the specification matches up to the emissions factors you've applied, see whether you need to apply a greater or a smaller amount of uplift there. So there's mechanisms in place there, but what I would say is that between, say, OneClick, which is obviously behind a paywall, you can pay for a license, they have something like 50,000 EPDs on there. The built environment carbon database has something like 60,000 free to access EPDs, environmental product declarations, which are sort of emissions factors for LCAs that we can use. And that ranges through from concretes through to steels, through to different types of carpet that you might fit in, say, communal areas or in high-rise flats and stuff. So as an industry, there is more data being shared, but the real push at the moment is that, yes, we have some generic ones available, but we need manufacturers to come in and sort of provide some detailed stuff to improve the accuracy of the assessments.
Sure. I guess this sort of linked to that around the sort of the disclosure, at least, is a question here that is the risk that the monitoring and reporting, and this is the bit you talked about towards the end, will drive companies only to report projects that have gone well. So I suppose the wider question is, what's the level of sort of mandatory reporting that's going to be required, or is it just a case of showing the shiny projects that have gone well and the rest of it gets sort of pushed under the carpet a bit?
So I guess, it depends where we go in terms of the regulation. So, it links back to saying, should it be part of the planning process? So if it becomes part of the planning process, then you can't hide behind all the good ones that went well. And if you've got a third-party accredited PAS 2080 system, well, that gets audited yearly. So they'll pick up pretty quickly if you're hiding the fact that you only make one good project a year in terms of carbon because you need a new case study to sell to clients. It's like everything. Everything is open to abuse. You can sort of, it's just more about people understanding and wanting to get involved with it, I think, is the problem. I think if everyone, as a construction industry, if everyone's doing it, then, the transparency will become there. And transparency, I think we've seen that quite a lot. Well, I've seen it. If we take again National Highways, for example, they did a press release the other day where they put their hands up and said, look, our original baseline was 30,000 tons too light. It was too small because of the way because of the boundary we set, and we've changed it to match with our financial reporting. So we need to change all our results. So if a company like National Highways can stick their hands up and go, look, we got it wrong, this is the sort of leadership that we need from the large players in the industry that hopefully will be matched by everyone else. So, yeah.
I suppose probably it's a final question then, and I guess, again, sort of linked to that, but going back down the supply chain to suppliers, the question is, are suppliers being required to accurately report on the embodied carbon in the products to allow the accurate WLCA? And I guess, National Highways could be the client and the supplier could be, the tier one contractors, or it could be literally down to the people manufacturing the bits and bobs that are going into construction.
So I think we have seen it, and I know HS2 is a contentious issue, but if you look at the carbon management system they came up with ahead of this PAS, it was very detailed and it was very clear about what we needed to do and what contractors needed to provide. And we are seeing that a lot more from some of the tier ones, especially. They have their own whole life carbon specification that they provide to their subcontractors and to their consultants to sort of price against. So we are definitely moving in the right direction. And again, we could build on that with, say, the NHS and sort of government contracts requiring a PPN 0621, which is like a light touch reduction plan, which does require you to consider a few of your emissions. So the frameworks are starting to become clearer with what they're expecting on whole life carbon. And I think once it's there, it will filter on down. I just think in terms of, as I mentioned at the start, in terms of like maturity of understanding, we're probably maybe 6 or 7 years behind where we are with maybe energy efficiency And there's a chance to sort of not make the same mistakes maybe with like the EPC system that we made there, which doesn't necessarily affect in-use performance. So I think we'll be able to take that learning with an industry and sort of with things like Part Z and a few other things. I think we should be able to get where we want to be.
Great, that's a good positive note to end on. Thank you very much again, Jamie, for that. That's been fascinating. Just to say that we didn't get around to answering all the questions, but what we will do is send a list of them to Jamie, and he will be able to email directly back with answers to the ones that haven't been answered today. Just final thing, I've forgot to mention the next First Thursday Club for Thursday is on the 2nd of November, and that's going to be how the approach to BNG will differ in Wales and Scotland, and that's going to be with Mark Lang from RSK Wilding. But apart from that, I hope you have the rest of a good day, and we'll see you next month. Thanks.